It began with a whisper, a quiet change in the light, a thin, dusty veil drawn across the sky. From the great Sahara, a cloud of the finest sand lifted into the air. It traveled silently over the sea, a rust-colored phantom journeying north. It crossed over Spain. It drifted over France. It settled like a fine powder across much of Europe. People woke up to strange, beautiful, and unsettling sights. The morning sun glowed with an eerie orange light. A fine, gritty film-coated cars. A fine, gritty film-coated windowsills. A fine, gritty film-coated garden statues. This was not entirely new. The Sirocco wind, the dust from the south, is an ancient phenomenon. But this time, a new study attached one word to this dust, and that one word makes us all stop. That one word makes us all hold our breath. Radioactive. The very idea feels wrong, doesn't it? It sits uncomfortably in the mind. The Sahara speaks to us of vast, empty beauty. Sun-scorched dunes, endless horizons. We think of heat, we think of sand, we think of wind. Yet, a new scientific paper suggests this dust may be carrying trace amounts of radioactive elements. And as soon as that word was spoken, the news spread like wildfire. Questions began to ripple through our communities, through our homes, through our own hearts. Are we safe? Is the very air we breathe a threat? What does this mean for our children playing in the park? These are not small questions. These are deep, primal fears. And we all know that fear can travel so much faster than the truth. So what was this study really? What did the scientists in their labs actually find? Well, they did something quite simple. They collected samples as the dust settled from the sky. They put those samples through rigorous tests, looking for things our eyes cannot see, searching for chemical fingerprints of various elements, including those that give off radiation. What they found was surprising. They detected levels of certain elements, like cesium-137. Those levels were slightly higher than expected. Important, the numbers were very, very small. Overall, radiation levels were, in almost all cases, well below public health safety limits. But the discovery that these particles could travel so far was profound. The study raised more questions than it answered, and that is where our journey begins. Not with panic, but with questions. How does dust travel thousands of kilometers to our doorsteps? What does radioactive mean in this context? Why would desert sand carry it? We must separate chilling headlines from calm, collected facts. We need to understand the science, and we need to understand the human story. How news affects feelings, choices, and well-being. This is not just about dust. It's about how we process fear. It's how we find our way back to facts. It's how we live with courage and wisdom amid unknowns. Let's take a deep breath, together, and let's look for the truth. Well, let's do that. It is almost impossible to truly imagine its scale. It is the largest hot desert on the entire planet, a vast sea of sand and rock stretching across North Africa. Now, picture the wind, a powerful, swirling force that can lift the very finest, lightest grains of sand from the desert floor. These particles are microscopic, lighter than a feather's touch. Once they are lifted, they don't just fall back down. They begin a journey. They ride the currents of the air, ascending high into the atmosphere, sometimes miles above the Earth. There, they join the planet's great weather systems, becoming one with the clouds and the wind. These tiny travelers can stay airborne for days, even weeks, embarking on an epic voyage. This is not a short trip across a field. This is a transcontinental migration. Air currents can carry this dust for over 3,000 kilometers, easily crossing the Mediterranean Sea and reaching deep into the heart of Europe. We see the evidence after it arrives. It can mix with raindrops, creating what some call muddy rain that streaks our windows. It settles on rooftops, in our gardens, and in our soil. It lands on the leaves of trees and the petals of flowers. Every single grain, no matter how small, has completed a journey that is nothing short of extraordinary. These dust events are a powerful reminder that our world is interconnected in ways we rarely stop to consider. The air that fills our lungs today might have been sweeping across a dune in Algeria just last week. But this dust is not just simple sand, it is a vessel. As it travels, it carries more than just its own mineral properties. It can carry microscopic life, like bacteria and fungi, from one ecosystem to another. It carries the rich minerals of the desert, which can sometimes act as a fertilizer for forests and oceans far away. And as it passes over populated and industrial areas, it can also act like a sponge. It can pick up pollutants from the air, gather particles from factory smokestacks, car exhaust, and other man-made sources. This is where the story takes a turn. Some of these man-made particles, left over from decades of industrial activity or even old nuclear tests, can be radioactive. The dust becomes a collector, a time capsule of the air it travels through. Radioactive. That word has so much power. It conjures images of danger, of invisible threats. In simple terms, something is radioactive when it is unstable and releases tiny bursts of energy to become more stable. This energy can, in very high doses, damage living cells. It's in the rocks beneath our feet, in the food we eat, and in the cosmic rays that shower down from space. The question here isn't whether radiation exists, it's about the dose. The study found that the Sahara dust had picked up a cocktail of particles, some natural and some man-made, creating a unique and slightly more radioactive signature than ordinary dust. The journey of the dust is also the journey of our planet's history, both natural and human. Let's talk about that one word, radioactive. It stops a conversation. It makes a headline scream. Why does it have such a hold on us? Because it represents an invisible force, something we cannot see, something we cannot taste, something we cannot smell, but that we have been taught to fear. And that fear is not entirely unfounded. We know that high levels of radiation are incredibly dangerous. But when we hear that word attached to something as natural as dust from the desert, it creates a deep sense of confusion and anxiety. Is a place of natural beauty now a source of unseen harm? So why would dust from the Sahara be radioactive in the first place? There are two main reasons, and it's important to know them both. First, there is a natural component. The Earth's crust, including the rocks and soil in the Sahara, contains naturally occurring radioactive elements. Things like uranium, thorium, potassium-40 have been in the ground for billions of years. When the wind erodes these rocks into fine dust, those tiny grains carry with them a faint, natural radioactive signature. This is a baseline level of radiation that is a normal part of our planet's geology. It's been happening for millennia and is not, by itself, a cause for alarm. It is part of the natural world we live in. The second reason is the one that gives us pause. It involves human activity. Over the past century, various activities have released artificial radioactive particles into the atmosphere. The most significant of these were the atmospheric nuclear weapons tests conducted by several countries, primarily between the 1940s and the 1960s. Those explosions sent radioactive fallout high into the stratosphere, where it has been slowly circulating and settling back to Earth ever since. Some of these tests were even conducted in the Algerian Sahara. Additionally, nuclear accidents like Chernobyl in 1986 released radioactive isotopes, like cesium-137, that were carried across Europe by the wind. These particles settle on the ground, becoming part of the topsoil, and can be picked up again by powerful winds. So, when the Sahara dust travels, it's not just carrying its own natural radioactivity. It can be picking up and resuspending these older man-made particles that have long since settled on the ground. Think of it like a duster wiping over a surface that hasn't been cleaned in decades. It picks up not just the new dust, but also the old. This is what the scientists found. A mix. They found the natural elements they expected, but they also found traces of things like cesium-137, a telltale sign of man-made fission from past events. The dust, therefore, tells a story not just of the desert, but of the atomic age. It connects the ancient sands with our more recent and more complicated history. It's easy to get lost in the fear of a word like radioactive, but the data gives us perspective. The study measured the concentration of these radioactive elements in the dust. They found levels that were, in some cases, higher than what is considered the normal background level for the areas where the dust was collected. But here is the most important part of the entire story. The measured levels were almost always far below the official safety limits for public health set by governments and international health organizations. Those safety limits are there for a reason. They are established with a huge margin of safety to protect every single one of us. Let's put this into a context we can all understand. We are exposed to small amounts of radiation every single day. This is called background radiation. We get it from the sun and stars, cosmic rays. We get it from the rocks and soil under our feet, terrestrial radiation. We even get it from inside our own bodies, from the food we eat. Did you know that bananas are slightly radioactive because they are rich in potassium, which includes a tiny fraction of the natural radioactive isotope, potassium-40? Eating one banana gives you a tiny, harmless dose of radiation. The additional dose you might receive from being outside during a Sahara dust event is, according to the current data, comparable to or even less than the dose from eating a few bananas. Think about a long-haul flight. When you fly in an airplane at 35,000 feet, you are higher up in the atmosphere and less protected from cosmic rays. A single flight from New York to Los Angeles can expose you to a dose of radiation that is many, many times greater than what you would get from the dust. Yet we don't think twice about getting on that plane. The scientific consensus is that the health risk from the radioactive elements in this dust is, for the general population, extremely low. It is not zero, and that is why scientists are studying it. But it is low enough that it should not be a source of daily panic or fear. It is a scientific curiosity to be monitored, not an immediate public health crisis. This is the balance we must find. We must take the scientists' concerns seriously. They are right to say that we need more studies. We need to monitor this over the long term, understand hotspots, and possible soil accumulation. But we must also hear them when they say the current risk is low. The facts matter, the numbers matter. They are the guardrails that keep our fear from running away with us. The data doesn't tell us to hide, it tells us to be aware, to be informed, and to keep things in perspective. The dose makes the poison, and in this case, the dose is very, very small. Beyond the numbers in the scientific charts, there is another story unfolding. It is the human story. The story of how this news lands in our hearts and in our homes. Imagine a mother, let's call her Sophie, living in a small town in northern France. She wakes up one morning and the sky outside her window has a strange orange glow. Her two young children are excited. They think it looks like a magical sky from a storybook. They want to rush outside and play. But then, Sophie scrolls through the news on her phone. She sees the headline, "Radioactive Sahara Dust Over Europe." Her heart sinks. The magic of the orange sky instantly turns into a source of dread. Suddenly, her home, which once felt like a safe haven, now feels like a fortress against an invisible enemy. The children are begging to go to the park, to ride their scooters on the sidewalk. But all Sophie can picture is them breathing in this contaminated air. She can't see the radiation, she can't feel it, but the fear of it is overwhelming. She tells the children they have to stay inside today. "The air is a little bit dirty," she says, trying not to scare them. The children are disappointed. Their energy turns to restlessness. They start to bicker. The joyful morning she had envisioned dissolves into a day of frustration and confinement, all because of a headline. This is the human angle that we cannot ignore. The psychological impact of fear is real, and it is powerful. News of an invisible threat can create a pervasive anxiety that changes our behavior. We might stop opening our windows for fresh air. We might cancel a walk in the woods. We might keep our children indoors, away from the sunlight and the simple joy of outdoor play. These small decisions, born of a desire to protect, can have unintended consequences. They can lead to a sense of isolation and a feeling that the world outside is no longer safe. This is the story of Sophie, but it is also the story of thousands, perhaps millions, of people who heard this news and felt that same knot of fear in their stomachs. It speaks to a deeper vulnerability we all share. We want to do what is best for our families. We want to keep them safe from harm. When the potential harm is something as mysterious and frightening as radiation, our protective instincts go into overdrive. The mother's dilemma is a profound one. In trying to protect her children from a very small, theoretical risk, did she inadvertently deny them the very real, immediate benefits of fresh air, exercise, sunlight? This is the complex emotional calculus that this kind of news forces upon us. It's a story not just about dust in the air, but about the weight of worry in a parent's heart. Section 6. There is a deep and scientific connection between the world outside and the world within us. Our moods are not created in a vacuum. They are profoundly influenced by our environment, especially by light. When sunlight enters our eyes, it triggers a chain reaction in our brain. It helps our bodies produce a powerful chemical called serotonin. Many of you have probably heard of it. Serotonin is often called the feel-good chemical. It helps to regulate our mood, making us feel happier, calmer, more focused. It also plays a vital role in our sleep cycles and our appetite. Quite simply, sunshine is a natural antidepressant. It lifts our spirits in a way that nothing else can. Now, think about what happens when we are deprived of that light. For many people, especially in parts of the world with long, dark winters, this can lead to a condition known as seasonal affective disorder, or SAD. It's a very real form of depression that follows the seasons. People with SAD can feel lethargic, unmotivated, and sad. They may sleep more, crave carbohydrates. The primary treatment for SAD is light therapy, which mimics natural sunlight to help the brain produce more serotonin. This shows us just how essential light is to our mental and emotional well-being. It is not a luxury, it is a biological necessity. This is where the fear of the dust creates a new problem. If the news of radioactive dust makes us afraid to go outside, we are willingly cutting ourselves off from our most powerful natural source of mood elevation. We are choosing the shadows over the sun. Sophie, the mother who kept her children inside, was acting out of love and fear. But the consequence was a day spent indoors, away from the light that their growing bodies and minds so desperately need. If this becomes a pattern, if every time the sky looks a little hazy, we lock our doors and draw our curtains, we risk creating a mental health issue in our attempt to solve a physical one. We could be worsening the very real problem of anxiety and seasonal depression. So we have to hold two truths at once. The first truth is that we should be aware of our environment and potential pollutants. The second, equally important truth is that hiding from the world is not the answer. The health benefits of spending time outdoors, the sunlight for serotonin, the fresh air for our lungs, the exercise for our bodies, the connection with nature for our souls, are immense and scientifically proven. They far, far outweigh the very small, hypothetical risk posed by the trace elements in the Sahara dust. We must not let an amplified fear rob us of the simple, profound healing power of a walk in the sun. Second, you don't need to hide from the world. On days with heavy dust, it's sensible to take simple precautions, especially if you or your family members have asthma or other respiratory issues. You might choose to limit strenuous outdoor exercise, like long-distance running. You could keep your windows closed to prevent the dust from settling inside your home. But this does not mean you have to seal yourself off completely. A walk to the store, sitting on a park bench, or letting children play in the yard is still perfectly fine. The key is moderation and awareness, not isolation. Remember the immense benefits of sunlight and fresh air for your mental health. Do not sacrifice your well-being for an unsubstantiated fear. Third, you can take control of your immediate environment. The dust that enters your home will eventually settle on surfaces. So do what you would do for any spring cleaning. Use a damp cloth to wipe down windowsills, tables, other hard surfaces. This simple act physically removes the dust particles, trapping them in the cloth. Using a vacuum cleaner with a HEPA filter can also be effective at capturing fine particles from your carpets and air. This is not just good advice for Sahara dust. It's good practice for creating a healthier indoor environment in general. Taking these small, tangible actions can give you a powerful sense of agency and reduce your anxiety. Finally, listen to your own body and your own intuition. If you are feeling particularly anxious about this, talk about it. Share your concerns with a friend, a partner, or a family member. Sometimes, just voicing a fear can rob it of its power. And if you have specific health concerns, especially for vulnerable individuals like infants, the elderly, or those with pre-existing conditions, the best thing you can do is consult your doctor. A medical professional can offer you personalized advice based on facts, not fear. Taking these small, proactive steps will help you replace anxiety with action, and that is where your true power lies. Section 8. When we look up at that dusty sky, we are seeing something profound. We are seeing a visible manifestation of a truth we often forget. We are all connected. We live under one shared sky. The air does not recognize the borders we have drawn on our maps. A gust of wind that begins in the heart of Africa can and does touch the lives of people in a city in Germany. This journey of the dust is a powerful, humbling lesson in global interconnectedness. It shows us how ecosystems are linked, how the health of one part of the planet can influence another, thousands of miles away. It reminds us that we are not islands. We are part of one single, intricate, and fragile system. This interconnectedness carries with it a deep responsibility. The fact that the dust can carry traces of man-made pollution from decades ago is a sobering thought. It means that the consequences of our actions do not simply disappear. The fallout from nuclear tests in the 1950s did not just vanish. The pollution from industrial accidents does not stay in one place. It enters the Earth's systems, the soil, the water, and the air, and it continues to circulate. The dust is like a messenger from the past, reminding us that our choices have long-lasting, far-reaching impacts. What we put into our environment today will be part of the world our grandchildren inherit tomorrow. This story, then, is a call to action. It is a call for greater global cooperation in monitoring our environment. Science gives us the tools to see and understand these complex processes. One study is just a single data point. To get the full picture, we need more. We need sensors in more places. We need to regularly test our air, our soil, and our water. We need to support the scientists who do this vital work, who give us the information we need to make wise decisions, both as individuals and as a global community. Investing in science and environmental monitoring is not a cost. It is an investment in our collective health and future. And it is a call to look at our own actions. While we cannot undo the mistakes of the past, we can certainly make better choices for the future. This story urges us to think more carefully about what we release into our atmosphere. It pushes us to support cleaner energy, more sustainable industries, and policies that protect our shared air and water. The journey of a single grain of sand from the Sahara to a windowsill in Paris is a microcosm of a much larger story. It is the story of our shared planet. It is a story that asks us to be better stewards of the only home we have. The responsibility is not just on governments or corporations, it is on all of us. Section 9. So, We come to the end of our journey, but the story of the dust continues. We have walked through the fear, we have looked at the science, and we have found our footing on the solid ground of facts and perspective. We know that the risk is low, but the phenomenon is real. We know that our mood is tied to the sun and that hiding indoors is not the answer. We have learned that small, practical steps can empower us and quiet our anxiety. We have been reminded that we live in a deeply interconnected world and that we share a responsibility for its well-being. But even with all this understanding, a question hangs in the air, as persistent as the dust itself. The news cycle will move on. Another story will capture our attention tomorrow. But the dust will return. The winds will blow again. The sky will turn orange another time. When it does, the word radioactive may surface again, bringing with it that familiar chill of fear. The true test of what we have learned is what we will do in that moment. Will we remember the context? Will we remember the numbers? Will we choose informed awareness over reactive panic? Will we protect not only our physical health with sensible precautions, but also our mental health by embracing the light? The choice will be ours to make, again and again. This is not a story with a simple ending, because science itself is a continuous journey of discovery. The last line of so many important studies is a humble and powerful one. More research is needed. This is not a sign of weakness. It is the engine of progress. It is a promise that the search for knowledge will continue.